And welcome to Technology Tap. I'm Professor Rod. Today we're going to talk about cloud service models and cloud deployment models. And we're also going to talk about Technology Tap Premium. Let's get to it. All right, welcome back. All right, today we're going to talk about the cloud a little bit. But first, again, I want to mention that we have a new service, Technology Tap Premium, for $5 a month. I already have a couple of people who are interested in it, so we'll see where it goes. And again, I'm looking for people who want to expand the community and be able to help you if you are having issues navigating the CompTIA, where you want to go, you're having issues with an exam, maybe I can help, or if you're having resume issues, interview issues, all that kind of stuff. So join Technology Tap Premium. All right, today we're going to talk about the cloud. Cloud computing services refers to the delivery of computing resources, including servers, storage, database, networking, storage, analytics, and intelligence over the internet. Instead of relying on local servers or personal devices, cloud computing allows users to access and use these resources remotely from a provider's data center. Here are some of the popular cloud computing services. Amazon Web Server is a comprehensive cloud platform provided by Amazon. It offers a wide range of services, including computing power, storage, database, machine learning, analytics, and more. Microsoft Azure. Azure is a cloud computing platform by Microsoft that provides services for computing, analytics, storage, and networking. It offers a device set of tools and services for building, deploying, and managing applications and services. Google Cloud Platform is a suite of cloud computing services provided by Google. It includes computing power, storage, big data, machine learning, networking, and more. Google Cloud Platform offers a range of products and tools for building and running applications in the cloud. IBM Cloud. IBM Cloud offers a broad set of cloud computing services and solutions, including infrastructure as a service, platform as a service, and software as a service, which we will go over. It provides services for computing, storage, networking, and more. Oracle Cloud Infrastructure is Oracle's cloud database platform that provides a variety of services for computing, storage, networking, databases, and applications. It offers a comprehensive suite of cloud services for building and running enterprise applications. Alibaba Cloud is a cloud computing service provided by Alibaba Group. It offers a range of services including computing, storage, network, database, analytics, and more. Alibaba Cloud is primarily focused on servicing business in China and the Asian Pacific. These cloud computing providers offer a wide array of services and solutions to cater to different business needs. Users can leverage these services to build and deploy applications, store and analyze data, run virtual machines, scale resources on demand, and take advantage of various other cloud-based capabilities. Now, the cloud has cloud service models. Cloud service models refer to the different categories of cloud computing services that are available. There are three primary cloud services. First is infrastructure as a service, which provides virtual computer resources over the internet. Users can access and manage virtual machines, storage, and network infrastructure. They have control over operating systems, applications, and configurations running on the infrastructure. Examples of infrastructure as a service include Amazon Web Servers, EC2, Microsoft Azure Virtual Machine, and Google Compute Engine. Platform as a service offers a platform and an environment for developers to build and deploy and manage applications. Developers can focus on coding and application development, while the cloud provider takes care of the underlying infrastructure, such as servers, operating systems, and networking. Platform as a service providers provide deployment tools, runtime environments, and other services to support the application development process. Examples of platform as a service include Google App Engine and Microsoft Azure Service. And then software as a service delivers software applications over the internet on a subscription basis. Users can access and use the software through a web browser or a thin client interface without the need to install and maintain the software locally. The software is hosted and managed by the software as a service provider who handles updates, patches, and infrastructure maintenance. Examples of software as a service applications include Salesforce, Google Workspace, and Slack. These cloud service models provide different levels of abstraction and flexibility for users, depending on their specific needs. While infrastructure as a service offers the most control and flexibility, it requires more management and configurations from the users. On the other hand, software as a service offers the highest level of convenience and ease of use, but with less control and customization options. Platform as a service falls in between, providing a platform for application development without the need to manage the underlying infrastructure. So let's go through each one. We can go over the first one, which is infrastructure as a service. They call it IaaS, stands for infrastructure as a service. It is a category of cloud computing service that provides virtual computing resources over the internet. With infrastructure as a service, users can access and manage virtualized infrastructure components such as virtual machines, storage, and networking without the need to invest in and maintain physical infrastructure. Here are the keys and benefits of infrastructure as a service. Virtualized infrastructure. This offers virtualized computing resources, including virtual machines, storage, and networking. Users have control over these resources and can configure them based on their specific requirements. Scalability. This platform allows users to scale their resources up or down as needed. This scalability is particularly useful for handling fluctuating workloads or accommodating business growth without the need to invest in additional hardware. Flexibility provides users with flexibility to choose and configure the components of the infrastructure. They have control over the operating systems, applications, and middleware running the virtual machines. Cost efficiency with infrastructure as a service. Users can avoid upfront infrastructure costs and only pay for the resources they use. They can also save costs by eliminating the need for hardware maintenance, upgrades, and physical infrastructure management. Rapid provisioning. Infrastructure as a service enables quick provisioning of computing resources. Users can create machines and deploy applications within minutes, reducing the time required to set up infrastructure for their projects. Disaster recovery and backup. Many infrastructure as a service providers offer built-in backup and disaster recovery solutions. Users can replicate their virtual machines and data across multiple geographical locations, ensuring data protection and business continuity. Geographic expansions. The providers have data center in various regions around the world. This enables users to deploy their applications closer to their target audience, reducing latency and improving performance. So some examples of these, again, include Amazon Web Service, Elastic Compute Cloud, Microsoft Azure Virtual Machines, Google Compute Engine, and IBM Cloud Infrastructure. Next, we have Platform as a Service, or PaaS. It is a category of cloud computing services that provides a platform and an environment for developers to build and deploy and manage applications without having to worry about the underlying infrastructures or the complexity of server management. With PaaS, developers can focus on coding and application development while the cloud provider takes care of the underlying hardware, operating systems, and network infrastructure. PaaS offerings typically include development tools, runtime environments, and other services to facilitate the application development process. Here are some key features of PaaS. Deployment environment. PaaS provides developers with complete development environment, including tools, libraries, and frameworks. This allows developers to write, test, and deploy applications without having to set up their own development environment. Scalability. PaaS platforms offers the availability to scale applications easy. They provide mechanisms to automatically scale resources up or down based on demand, ensuring that applications can handle varying levels of traffic and workload. Reduce infrastructure management. PaaS eliminates the need for developers to manage underlying infrastructures such as servers, operating systems, and network configurations. The cloud provider takes care of these aspects, allowing developers to focus solely on application development. Faster time to market. PaaS enables developers to streamline the application development process with pre-built components, development tools, and deployment automation. Developers can accelerate their development cycle and bring applications to market more quickly. Cost efficiency. PaaS allows a pay-as-you-go processing model where users are charged based on the actual use of resources. This helps organizations save costs by eliminating the need for upfront infrastructure investments and reducing operational expenses. Collaboration and integration. PaaS platforms often provide collaboration features that enable teams to work together on projects more efficiently. Additionally, they offer integration capabilities to connect with other services and systems, facilitating seamless data exchange and interoperability. Some examples include Google App Engine, Microsoft Azure App Service, IBM Cloud. These platforms offer various tools, frameworks, and services tailored to the different programming languages and application types to make it easier for developers to build, deploy, and manage their applications in the cloud. Last but not least is SaaS, stands for Software as a Service. It is a cloud computing model in which software applications are delivered over the internet on a subscription basis. Instead of installing and maintaining software on individual computers or servers, users can access and use the software through a web browser or thin client interface. Here are the key features and benefits of SaaS. 1. Accessibility. SaaS applications are accessed from any device with an internet connection and a web browser. User can access the software and the data from anywhere, making it convenient for remote work and collaboration. Easy deployment. SaaS eliminates the need for users to install and configure software on their local machines or server. The software is hosted and managed by the SaaS provider who handles tasks such as updates, patches, and infrastructure maintenance. Scalability. SaaS allows users to scale their software usage according to their needs. They can easily add or remove users increase or decrease storage space, and adjust resources as their requirements change without the need for significant infrastructure changes. Cost efficiency. SaaS allows a subscriber-based pricing model where users pay a recurring fee for the software usage. This eliminates upfront software licensing costs and reduces the need for hardware and infrastructure investments. The SaaS provider is responsible for managing and maintaining the software, which further reduces IT overhead costs. Automatic updates. SaaS providers handle the software updates and upgrades on their end, ensuring the users have access to the latest features and security patches. Users do not need to worry about the manual updates or compatibility issues. Customization. SaaS applications often provide customization options to tailor the software to a specific needs of the user. Customization can include user interface, settings, workflows, and integration of other software systems. Multi-tenancy SaaS applications typically follow a multi-tenant architecture where multiple users or organizations share a common instance of the software. This approach allows for efficient resource utilization, easier management, and cost savings. Popular examples of SaaS applications include customer relations management systems like Salesforce, productivity suites like Google Workspace, Microsoft 365, project management tools like Trio, and communication and collaboration platforms like Slack and Microsoft Teams. These SaaS applications offer a wide range of functionality and cater to various business needs across different industries. So that takes care of that. Now they have cloud deployment models. So deployment models refer to the ways in which cloud computing services are deployed and made available to users. There are four primary cloud deployment models. Public cloud, a public cloud deployment, the cloud infrastructure and services are owned and operated by a third-party cloud service provider. These resources are shared among multiple organizations or users who have access to the services over the internet. Public cloud deployments offer scalability, cost efficiency, and flexibility as users only pay for the resources they use. Examples of public cloud include Amazon Web Servers, Microsoft Azure, and Google Cloud Platform. Let's do a little bit deeper dive on that. So public cloud refers to cloud computing model in which cloud resources, services, and infrastructure are owned and operated by third-party cloud service providers and made available to the general public or a large number of organizations. These resources are accessible over the internet, and the users can provision and utilize them on demand, paying for the resources they consume. Here are some key characteristics and benefits of public cloud. Shared infrastructure. In a public cloud, the underlying computing infrastructure, such as servers, storage, and networking, is shared among multiple users or organizations. This allows for efficient resource utilization and economics of scale, resulting in cost savings. Scalability and elasticity. Public cloud offers scalability, allowing users easily to scale their resources up or down based on demand. Users can rapidly provision additional resources to handle peak workloads or scale down during periods of low demand. This flexibility helps organizations optimize resources and usage and control costs. Pay-as-you-go model. Public cloud providers typically follow a pay-as-you-go pricing model. Users are billed for the actual resources they consume, such as computing power, storage, and data transfer. This eliminates the need for upfront capital expenditures and allows for cost-efficient resource allocation. Global accessibility. Public clouds have a geographically distributed infrastructure with data centers located in various regions worldwide. This enables users to access cloud services and deploy applications closer to the target audience, reducing latency and improving performance for geographically dispersed users. Service Verity public cloud providers offer a wide range of services and solutions to meet diverse computing needs. These services may include infrastructure service, platform services, and software applications, data storage, machine learning, analytics, content delivery, and more. Users can leverage these services to build, deploy, and manage applications and services in the cloud. Reliability. Public cloud providers often have a robust infrastructure and redundancy measures in place to ensure high availability and reliability. They employ data replication, backup systems, and disaster recovery mechanism to minimize downtime and to protect against data loss. Ease of management. Public cloud providers handles infrastructure management tasks, including hardware maintenance, software updates, security patches, and network configurations. This relieves users from the burden of managing the underlying infrastructure, allowing them to focus on their core business activity. Popular public cloud providers include Amazon Web Service, Microsoft Azure, Google Cloud Platform, and IBM Cloud. These providers offer a broad range of services and have an extensive global infrastructure to support various use cases and requirements. Next, we have the private cloud. Private cloud refers to a cloud computing model in which a cloud resources, services, and infrastructure are dedicated to a single organization. Unlike a public cloud, where resources are shared among multiple users or organizations, private cloud infrastructure is used exclusively by a single entity. Here are some key characteristics and benefits of private cloud. Ownership and control. In a private cloud, the organization has complete ownership and control over the infrastructure and resources. This allows for greater customization, security, and compliance as the organization can tailor the cloud environment to its specific needs and requirements. Enhance security and privacy. Private clouds offer a higher level of security and data privacy compared to public cloud deployments. Organizations can implement stringent security measures such as dedicated firewall, intrusion detection systems, and encryption protocols to protect sensitive data and applications. Compliance and regulatory requirements. Private cloud deployments are often preferred by organizations that operate in highly regulated industries such as healthcare, finance, or government sectors. Private cloud enables organizations to meet specific compliance requirements by maintaining control over data locations, access controls, and data governance. Customization and flexibility. Private cloud provide flexibility in terms of resource allocation, scalability, and performance optimization. Organizations can configure the cloud infrastructure to meet their unique computing needs, deploy custom application, and fine-tune performance parameters according to their specific requirements. Resource allocation and utilization. Private clouds allow organizations to allocate and utilize resources more efficiently with a dedicated infrastructure. Organizations have granular control over resource allocation and can optimize usage based on workload demands. This leads to better resource utilization, cost control, and performance optimization. Reduce latency. In certain scenarios, private cloud can offer lower latency compared to public clouds. By hosting the infrastructure closer to end users or critical applications, organizations can achieve faster times and improve application performance. Hybrid and multi-cloud integration. Private clouds can be integrated with public cloud or other private cloud deployments to form a hybrid or multi-cloud environment. This enables organizations to take advantage of the scalability and cost efficiency of public clouds while maintaining sensitive data. or critical workloads in a private cloud. It is worth noting that private cloud can be deployed on-premise using an organization's own data center, or they can be hosted and managed by third party. Examples of private cloud solutions include Microsoft Azure Stack, VMware vSphere, and OpenStack. Organizations opt for private cloud deployments when they prioritize data control, security compliance, and customization. While private clouds offer these benefits, they require higher initial investments, dedicated resources, and ongoing management compared to public cloud options. Next, we have the hybrid cloud. Hybrid cloud refers to a cloud computing environment that combines the use of both public and private clouds, allowing organizations to leverage the benefits of both deployment models. In a hybrid cloud, data and applications can seamlessly move between private and public cloud. Infrastructure provide flexibility, scalability, and control. Here are key characteristics and benefits of cloud. Flexibility and agility. Hybrid clouds allow organizations to dynamically allocate workloads and data between private and public clouds based on specific needs. It provides the flexibility to choose the most suitable environments for each application and workload, considering factors such as performance requirements, security concerns, and cost considerations. Scalability. Hybrid cloud offers scalability by leveraging the on-demand resources of the public cloud. During peak periods or when additional resources are required, organizations can easily scale out to the public cloud to handle increased workload. Conversely, when demand decreases, resources can be scaled back in the public cloud, optimizing cost efficiency. Data control and security. Hybrid cloud enables organizations to maintain control over sensitive data and critical workloads by keeping them in the private cloud. This is particularly important for industries with strict compliance or regulatory requirements. Data that is less sensitive or requires external collaboration can be stored and processed in the public cloud. Cloud optimizations. Hybrid cloud allows organizations to optimize costs by taking advantage of the cost effectiveness of public cloud resources for non-sensitive workloads or temporary projects. By leveraging public cloud services for these use cases, organizations can avoid the need for additional hardware investment and ongoing maintenance costs. Improved performance. Hybrid cloud enables organizations to optimize applications performance by strategically placing workloads in the most suitable environments. Latency sensitive applications can run in the private cloud closer to the users or critical data sources, while less latency sensitive applications can be deployed in the public cloud for scalability and global accessibility. Disaster recovery and business continuity. Hybrid cloud provides robust disaster recovery and business continuity solutions. Organizations can replicate the critical data and applications in both private and public clouds, ensuring data redundancy and reducing the risk of data loss. In the event of a failure or disaster, applications can be quickly restored from the backup environment. Seamless integration and portability. Hybrid cloud can facilitate seamless integration and data portability between private and public clouds. Organizations can leverage tools and technologies that enable easy migration, synchronization, orchestration of applications and data between the two environments. To implement a hybrid cloud, organizations need to establish connectivity between their private and public clouds, ensuring secure data transfer and integration. This can be achieved through technologies such as virtual private network, dedicated connections, or hybrid cloud management platforms. Organizations opt for hybrid cloud deployments when they have a mix of workloads, varying requirements such as sensitive data, compliance needs, scalability demands, or cost consideration. Hybrid cloud allows organizations to achieve a balance between control, security, flexibility, and cost optimization, providing an optimal cloud computing solution. And the last one is a community cloud, which is a cloud computing deployment model that is shared by multiple organizations or entities with similar interests, such as industry-specific requirements, compliance needs, or common objectives. In a community cloud, the infrastructure, services, and resources are collectively used and managed by the community members, providing a shared computing environment. Here are the key characteristics and benefits of a community cloud. Shared infrastructure. In a community cloud, the underlying community infrastructure is shared among multiple organizations or entities that belong to the same community. This allows for efficient resource utilization and cost sharing among the community members, resulting in potential cost savings. Common requirements. Community clouds are formed by organizations with similar needs, such as compliance requirements, industry regulation, or specific security standard. The community members can collaborate and define shared policies, governance models, and security controls that align with their most common objectives. Customization and flexibility. Community clouds offer customization options to meet the specific needs of the community member. The shared infrastructure can be tailored to accommodate specific applications, workloads, or configurations required by the community, enabling flexibility and adaptability. Enhanced security and compliance. Community cloud address the unique security and compliance requirements of the community members. Shared security measures such as access control, data encryption, and compliance frameworks can be implemented to meet the common standards and regulatory obligations of the community. Collaboration and knowledge sharing. Community clouds foster collaboration and knowledge sharing among the community members. Organizations within the community can share best practice, insights, and resources, leading to increased efficiency, innovation, and industry advancements. Cost sharing and resource optimization. By pooling resources and costs among community members, community cloud can provide cost sharing benefits. The community members can collectively invest in the infrastructure, maintenance, and management, resulting in reduced individual costs and optimizing resource utilization. Dedicated community support. Community clouds often provide dedicated support and services tailored to specific needs of the community. The cloud service provider or governing body overseeing the community cloud can offer specialized support, training, and consulting services to address the unique challenges and requirements of the community member. Community clouds can be deployed as private clouds, hosted and managed by third-party providers, or as hybrid clouds that are combined private and public cloud resources. The community members typically have shared governance and decision-making mechanisms to ensure the efficient management and evolution of the community cloud. Examples of a community cloud include government clouds that serve multiple government agencies, healthcare clouds catering to the healthcare providers, or financial service cloud servicing multiple financial institutions. These things, I know the bank has like a some kind of system that you can, like, if somebody commits scams or has like a negative, like opens up an account in Chase and leaves, and the account is like negative, they have a way of tracking that. They have a system, so that's an example of that. And I think the healthcare one are the ones where you go and they check if you have insurance. I think that's the one for the healthcare field. So they all share that. These community clouds are designed to meet the specific regulatory, security, and compliance needs of their respected communities. All right. That's going to do it for today. Thank you so much for listening. And remember to subscribe to Technology Tap Premium. On January 15th, we will be announcing the winner of the free voucher. Until next time. This has been a presentation of Little Chacha Productions, art by Sarah, music by Joe Kim. If you want to reach me, you can reach me at professorjrod@gmail.com and also on Instagram at professorjrod.